In the context of the environmental uses affecting grassland ecosystem, such as soil degradation and water scarcity, hydroponics emerged as innovative potential solution. This system, which allows plants to be grown without soils, offers significant advantage in areas where natural resources are limited. Through the use of nutrient solution, hydroponics can optimize water use and reduce pressure on soils, which in many cases are being impacted by overexploitation and climate change. We are teammates, and in this project, we explore how hydroponics can be applied to grow plants efficiently and sustainably, and how this technique could contribute to enhancing the resilience of grassland ecosystem in the face of global warming and desertification challenges. Below, we will present the details of our experience growing beans, analysis the plant growth under controlled conditions, and implication for the future agriculture.
We decided to use beans for this project because they are very easy to grow. But first, we put some beans to germinate to ensure that they grew. Once we saw a small root coming out of the bean, we decided to put it in the hydroponic system. The growth of the plant was a bit slow, but effective. We also used some fertilizer on it. In a period of 10 days, our plant grew considerably, going from 6 centimeters to 27 centimeters. Unfortunately, its growth stopped and the plant got weak due to the sudden change in the temperature.
Now, to carry out the hydroponic process after germinating the bean plant, a recycled 2.5 liter bottle was taken. One of the two holes were made in the top, the size of 2 nanometers yogurt containers. In this, the holes were first marked with a permanent marker and then cut with a scissors. Then, with a hot knife, a hole was made near the barrel's neck, the size of circumferences of a straw. Then the straw was inserted with silicone at 1 centimeter from the bottom of the barrel. After this, the barrel was filled to its maximum capacity, and 3 to 5 drops of fertilizer with nutrients for the plant were added. As for the plant, holes were made in the 2 yogurt containers with a hot knife at the bottom of the top half of the container. Then a small bed of less than 0.5 centimeters of stone was placed, and then clean plant was placed without any cotton residue. Then the container was filled to its maximum capacity with stones, and they were placed in the holes we made in the bottle, and the containers were covered halfway with water. With this, the hydroponic system was ready to rest into its work, making sure to change the water and fertilizer every 5 days.
In another case, the beans were germinated in cotton and then put in hydroponics with aquarium stones, and without fertilizer. Good growth was seen in the plant until day 10, when we noticed that it began to die. We believe it was due to the salt from the aquarium stones. However, in another case, other beans were planted in soil with fertilizer and then transplanted in hydroponics, also with aquarium stones, and in this one a great growth is noted. And now, observing the first plant in more detail, we realized that it had a kind of plague, so we assumed that was the reason it did not survive. To this day, that second case continues to absorb the tap water that we have been placing in it, but its roots are not noticeable at the bottom of the bottle as in the first case, which is why we removed the aquarium stone in the second case to verify the growth of the root. When doing so, we observe a slight growth in the root that is still very thin and a little rolled up to be seen underneath. From what we saw, this second case will take at least two more weeks to notice growth below in the bottle as the first case.
As possible results, we observed in growth plants under hydroponic conditions. Tests were conducted with 4 plants in total. 2 germinated in cotton and 2 planted in soil with fertilizer. Although one of the plants in the first case showed issues, possibly due to a pest, the other plants demonstrated favorable growth, especially in the second case, where fertilizer was used before transferring them to the hydroponic system. These tests allowed us to interpret key factors for healthy plant development and highlighted the potential of hydroponics as a sustainable agricultural method. Through this project, we explored how hydroponics can be applied to grow plants efficiently and sustainability. Using beans chosen for their ease of growth, we ensured proper germination before transferring the plants to a hydroponic system. Over 10 days, one of the plants showed significant growth, increasing from 6 to 27 centimeters. However, its development slowed due to a sudden temperature change, demonstrating the importance of environmental stability for successful hydroponic farming. These findings underscore the potential of hydroponic as a practical solution to address environmental challenge while advancing agricultural sustainability.